Hello, welcome to another video of Engineering Economics 2373. In this video I'm going to talk about the proper way to model and solve problems that contain P, A, and Fs. I'm going to discuss the most typical errors that the students have when trying to solve these type of problems. And in essence, the main problem is trying to solve the problems as if it was recipes. They are not recipes in the sense that you have to understand the math underneath it, and if you understand the math, the problem is very simple. If you, however, only try to apply the formula in one single step, chances are for longer problems you might get it wrong. So let's work with the problem so you will see what I'm talking about. Okay, let's consider this example. We have a problem in which we have 4 annuities. Each annuity is $500. Annuities happen at periods 1 through 4. And we can readily compute the present worth that is needed to be invested in order to be able to withdraw these 4 annuities as 500 times P given A, 10%, and 4. The value for this computation is $1,584. and 93 cents. So that doesn't represent any problem. Okay, so that's the first instance, and let's separate that result. Now let's say again that the annuities are 500, but now the annuities happen on years 7 through 8, and now we can compute the present worth as the let's see, present worth is 500 times, now we have 3 annuities, P given A for 10%, and we have 3 of those annuities, and given the formulas that we have, this P given A will bring the quantities of these cash flows on 7, 8, and 9 one period earlier, that's at t equals 6, but we need the numbers at t equals 0, so now we multiply times P given F 10%, 6 periods, and that would take that single quantity that we had hypothetically at t equals 6 back to t equals 0. When we compute this result just for this section, $701.88. So far so good. That doesn't represent much challenge. If we had all the cash flows in the same years as we did before, to combine, now we can combine both quantities together, and all we need to do is add the cash flow for the first part to the cash flow of the second part, and the total cash flow would be just adding these two quantities together, $2,286.81. And sometimes, let's see, if we're going from the 500 annuity to the present worth, that would be the way to do it. Of course, it could be that we have the present worth and now we want to solve the problem to figure out the annuities. Let's try to solve that problem. So now that we have this is the same problem, now we're asking what the annuity should be. Well, we already know the answer because we solved the previous problem. The answer should be 500. How do we come up with this answer? Well, the easiest way for us to understand it would be just to write the same equation that we had before. We know that the present value, which in this case is 2,286.81, should be equal to whatever the annuity is times P given A for 10% and 4, plus again the same annuity times P given A 10% and 3 times P given F 10% and 6 periods. When you do the operations, that gives you 500 as expected. However, most students will not represent the problem in this manner. They will try to make a shortcut that will give them problems. So what most students do? Well, students try to make a shortcut. So in theory, they say, well, if I wanted to solve just for the first part, I can solve just the expression a equals 2286, which is the present value, times a given p for 10% and 4 periods. That should give me the 500 I was looking for. The problem is that that is not true. That value actually becomes, as opposed to 500, that number is not 500. That number is now $721.42, because this quantity 2286 is enough to pay more than 500, because that already pays the 500 for the first 4 annuities plus the annuities in the last 3 years. In the second example, now they expect that 2286, when multiplying the factors p given a, 10% and 3, times f given p, 10% and 6, they expect that to be 500, and they have a surprise. Because now the answer is not 500, but $1,629.06. To make things even worse, they say, well, it cannot be only 721, because that takes care of the first part completely, and then 1,620, well, we have 1,629.06. So I'm going to add these two together, and then my complete answer is going to be the annuity is $2,350.48. Now, of course, this answer is wrong, because the right answer should have been 500. When you write the expression a equals p times a given p, 10% and 4, plus p times a given p, 10%, 3 times f given p, 10% and 6 periods, when you write that, you have to really check what you're trying to say, as opposed to just writing the question, because what you would be saying here is that the annuity is equal to the current present value set up to annuities, plus that same present value set to a different number of annuities, and then displace them, and then you're adding them all together. So what does that really mean? Does it mean that you are having both annuities and you have 2 times p at the beginning of the period, so you can pay the first part of the annuities for 4 periods and then the second part of the annuities for the last 3 periods? And then what do you mean when you add them? Are they going to happen in the first 4 years, or are they going to happen on the last 3 years, or are they going to happen all the time? There is no real interpretation, physical interpretation, to what's going on with this equation. So just don't write the equations in order to make it faster. What you need to do is go back to basics and write the equations so they actually become a expression of what's happening in your model. And what's happening in your model is precisely these expressions two together. We can we have the first part of the annuities, the first annuities 500 actually compute like that, and then you can add them together, or you can express that in a single equation. And that single equation would look like this one. And notice now that although we're trying to solve for a, what we really mean to say with the equation first is to actually make it meaningful in the perspective of the problem. And that now, after the fact that we have a meaningful equation, now the rest of it is just working with the algebra, and that should be your strategy. So please work on an accurate representation of the problem, and then just work the math.